Welcome back, as we now look at the types of reducers that you're likely to have to maintain. Many types and designs of reduction units are used throughout industry. The sizes, types and reduction factors are all dependent upon the workload and application. In practice, you are most likely to encounter single, double and triple reductions. A single reduction, as mentioned before, consists of one input gear, which we normally call a pinion, and one driven gear, often called the output gear. This terminology applies to spur, helical or bevel gear types. A double reduction involves two stages of reduction. Typically, an input shaft carries a pinion. The pinion drives a first stage reduction gear. This gear carries a second stage pinion, which drives a final stage output gear. In this manner, very high reduction factors can be built into a relatively small reduction unit. Triple reduction involves a further stage, whereby the second stage driven gear carries a pinion that drives the final output gear. In this manner, it is possible to create quadruple, which is 4 stages of reduction, and even quintuple, 5 stages of reduction. The need for such high reduction factors becomes more critical where large mechanical devices are being driven and where output speeds are to be very low. Let's now look at some designs and types of reducers. In broad terms, there are 3 major reduction types, namely inline reducers, parallel shaft reducers, and angle drive reducers. An inline reducer has its input and output shafts in line, that is, on the same axis. This configuration is also known as concentric. A parallel shaft reducer is made in such a way that the input, intermediate, and output shafts all lie parallel to each other. In many examples, the input shaft may even be on the same side of the unit as the output. Such a configuration is also known as a transfer box. Angle drive reducers generally imply a 90-degree change of rotational direction between the input and output shafts. For this reason, this type is usually known as a right angle drive. The most commonly seen type is the worm and wheel unit, such as this popular Radicon. Another common angle drive reducer is the bevel pinion drive. Note that this type most usually continues its reduction through parallel shafts. Reducers are also described with their reduction factor, and this is given on each unit's specification plate. As we have already defined reduction, let's move on to the next descriptive term, namely size. Size is a little more difficult to explain owing to the different methods that are used by different manufacturers. Size may be given as the physical dimensions of the unit assembly, or, as is the norm with worm drives, size refers to the distance between the shaft centers. Some sizes are given in a unit's kilowatt capacity, usually referring to the rated output of the reducer when driven by the recommended motor. There are no set rules about how size is determined. Most often you will have to refer to the various gear manufacturers' data for this detail. The way in which a reducer is fixed or mounted into position is another descriptive term you should know about. The commonest mounting is a foot mount, whereby the unit is secured to a bed or base plate using bolts or set screws through pedestal brackets, generally called feet. The next example we see is called a shaft mount, which means that the reducer is supported by the input shaft of the driven machine. A support arm, or brace, prevents the reducer from revolving. Similar to a shaft mount type is the flange mount, so called because the reducer's body is supported by a flange that in turn is bolted to the framework of the plant. No support brace is necessary for flange-mounted reducers. In yet another configuration, we see an integral reducer, so called because the drive motor is an integral part of the reduction housing. In such types, the pinion is usually fixed directly to the motor shaft. By now, it will be obvious to you that a reducer can take on any size, shape, and design. And no doubt you will come across others. In this program, you have been introduced to the most widely used geared reduction units. In the following programs, we shall explain and demonstrate procedures involved when maintaining reducers. This brings us to the end of the overview program. When you have completed the exercise in your workbook, you may move on to any of the following programs in this series.